Today we're going to start section 1.5, angle pair relationships. So our first relationship is complementary. Two angles are complementary if the sum of their measures is 90 degrees. Next we have supplementary. Two angles are supplementary if the sum of their measures is 180 degrees. And we have adjacent angles. Two angles that share a common vertex and side. So complementary and supplementary angles can either be adjacent or non-adjacent. They can share a common vertex and side, or they can not be touching at all and still add up to 90 degrees. Same thing with supplementary angles. They can share a common vertex and side, like angles 1 and 2 here, or they can be completely away from each other and just add up to 180 degrees. So pause the video and try the practice problems on your own. Just A, B, and C. So for A, we have a pair of complementary angles. These add up to 90 degrees. So we have 32 plus 58 is 90 degrees. So a pair of complementary angles is angle CAD and angle RST. Next, we have a pair of supplementary angles. So we have angle measure 122 and 58. 122 plus 58 is 180 degrees. So we have angle CAB and angle RST as our supplementary pair. And next we have adjacent. Remember, adjacent angles are next to each other. They're touching. They have a common vertex and side. So here their common vertex is A and their common side is ray AC. So we have angle CAD and angle CAB as our adjacent angles. Given that angle 1 is a complement of angle 2 and the measure of angle 1 is 68 degrees, find the measure of angle 2. Draw a picture. So here I drew my angles adjacent. Our key word here is complement, right? So our two angles are complementary. They're going to add up to 90 degrees. So the measure of angle 1 plus the measure of angle 2 equals 90 degrees. We are told that the measure of angle 1 is 68 degrees. So here I'm just going to plug in the measure of angle 1. So 68 degrees plus the measure of angle 2 is equal to 90 degrees. To solve for the measure of angle 2, I am going to subtract 68 from both sides. So the measure of angle 2 is equal to 22 degrees. So remember, complement, complementary, add up to 90 degrees. Given that angle 3 is a supplement of angle 4, and the measure of angle 4 is 56 degrees, find the measure of angle 3. So here our keyword is supplement, so our two angles are supplementary. They're going to add up to 180 degrees. So we say the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. We know that the measure of angle 4 is 56 degrees, so I can plug that into my equation. The measure of angle 3 plus 56 degrees is equal to 180 degrees. Here I am going to subtract 56 from both sides. So the measure of angle 3 is equal to 124 degrees. So remember, supplement, supplementary, they must add up to 180 degrees. All right, moving on to some more angle pairs. So here we have a linear pair first. I just want you to notice the word line in linear pair, right? So a linear pair, two adjacent angles whose non-common sides are opposite rays. So if we take a look at this first example here with angles 1 and 2, right? They're non-common sides. So they don't share this side of the angle and they don't share this side of the angle. Our two non-common sides form opposite rays, right? They have the same starting point and they go off in exact opposite directions, forming a line, right? So that's where they get the word linear from, linear pair. The non-common sides are opposite rays, which forms a line. So angles 1 and 2 together are a linear pair because their non-common sides are opposite rays and form a line. Next we have vertical angles. So our vertical angles are two angles whose sides form two pairs of opposite rays. So if we just take a look at angles 3 and 5 for now, right? 3 and 5 are going to be vertical angles because their sides form opposite rays, right? If we start at the vertex and go this way, and then start at the vertex and go in the exact opposite direction, right? Those two sides form opposite rays. And then same thing with the other two sides. If we start at the vertex and go down into the right, and start at the vertex and go the exact opposite direction, those sides form opposite rays as well. So vertical angles are angles that are directly across from each other, directly across the vertex. So in this case, angles 3 and angle 5, and then also angles 4 and angle 6. So those are our two pairs of vertical angles here. Now I just want to point something out. If I were to draw angles like this, right, and to label them angle 1 and angle 2, although these angles are across from each other, across from the vertex from each other, right, these are not considered vertical angles because their sides don't form opposite rays. This side and this side do not go in exact opposite directions. If this side was here instead, right, then 1 and 2 would be considered vertical angles. But because that side does not form opposite rays and does not form a line, those are not vertical angles. So these are not vertical angles because those sides do not form opposite rays. All right, let's identify pairs, angle pairs. So pause the video and try it yourself. There's going to be 2 linear pairs and 1 vertical angles. So here our linear pairs are angles 1 and angle 5, and then angle 5 and angle 4. Those are our 2 pairs. And for vertical angles, we only have 1 pair, angle 1 and angle 4. All right, here we want to find the measure of angle ABD and angle DBC. So these two angles would add up to 90 degrees. They are complementary, right? So we have 4x plus 6x equals 90 degrees. And we know these add up to 90 because CBE is a right angle, which means CBA is also a right angle. So if we combine like terms here, 10x is equal to 90, divide by 10 on both sides, x equals 9. After we solve for x, we can plug that in to solve for the angle measures. So the measure of angle ABD is equal to 4 times x, so 4 times 9, which is 36 degrees. And the measure of angle DBC is equal to 6 times x, so 6 times 9, which is 54 degrees. And 36 plus 54 is 90 degrees, so we can just check our work that way, because we knew these angles had to add up to 90 degrees. So here we have to find the measure of angle ABD and DBC. Here we have supplementary angles, or a linear pair, right? The non-common sides form opposite rays, which forms a line. And we remember from the beginning that angles like this that form a line are supplementary. They add up to 180 degrees. So we have 12x minus 7 plus 7x minus 3 is equal to 180. We combine like terms. 19x, negative 7 minus 3 is minus 10, is equal to 180. I'm going to add 10 to both sides. 19x equals 190, and then I'm going to divide by 19 on both sides. X is equal to 10. Now that we found x, we can plug in to find the measure of our angles. So the measure of angle ABD equal to 12 times 10 minus 7, which is 120 minus 7, which is 113 degrees. And then the measure of angle DBC is equal to 7 times 10 minus 3, which is 70 minus 3, which is 67 degrees. And if we add 113 and 67, we do get 180, so it checks out. All right, proving angle pair relationships. So just some theorems here. The right angles congruence theorem, right? All right angles are congruent. That makes sense because if it's a right angle, it has to measure 90 degrees. So that means all right angles are congruent. They have equal measure. The linear pair postulate. If two angles form a linear pair, then they are supplementary. So they add up to 180 degrees. So linear pair, right, they form a straight angle. The opposite rays form a line. We know that lines and straight angles measure 180 degrees, so a linear pair is supplementary. And then the vertical angles congruence theorem, all vertical angles are congruent. So all vertical angles have the same measure. All right, so I'm going to do one with you. You're going to do two on your own. So here we know the measure of angle 1 is 112 degrees, and we want to find the other three angles. So right off the bat, I know angle 1 and 3 are vertical angles. So I know that the measure of angle 3 is also 112 degrees because they are congruent, right? Angle 1 and angle 3 are congruent. I know the angle 1 and angle 2 form a linear pair. Right, so to find the measure of angle 2, I can do 180 minus 112, and I get 68 degrees. So the measure of angle 2 is 68 degrees, and then the measure of angle 2 and the measure of angle 4 are congruent because they are vertical angles, so I know the measure of angle 4 is also 68 degrees. Pause the video and try number 2 on your own. Number 2, we know the measure of angle 2 is 67. Angle 2 and angle 4 are vertical angles, so angle 4 also measures 67 degrees. Then we have angle 1 and angle 2 are a linear pair, so we do 180 minus 67. We get 113 for the measure of angle 1. And then angle 1 and angle 3 are congruent because they are a linear pair. We want to find the value of x and the measure of angle 2. So first we have to use this linear pair here to solve for x. 3x plus 1 plus 32 is equal to 180 degrees. Because these are a linear pair, we know they are supplementary. We solve for x here, we get x is equal to 49. Then we can use that value, plug it in to this green highlighted angle to find the measure of this angle. We plug it in, we get 148 degrees for this angle. We know that this angle and angle 2 are vertical angles, so those angles are congruent, so the measure of angle 2 is also 140